recording in progress.
I went
Continue or leave meeting. Well, that's a good choice. I'll continue.
Wow. Supposed to be a new update. I didn't know it gave you that choice now.
Oh, really? Get
I
the
didn't know
hell
that
out of
either.
Dodge.
That's interesting.
Flashing leave on my little screen here. So.
Oh, we still got people rolling in. So I'm going to just hold for another couple seconds.
Sure, that's fine. Whispering doesn't help. We can hear you anyway.
Okay.
These microphones are marvelous today, aren't they?
Dr. Fleisch.
Oh, hey, here we go. How you doing?
Doing well. Good to see you.
Good to see you, Mark Carmel. Got a little UFO action going here.
Well, yeah, you got your UFO. Yeah.
Oh, that wasn't even on purpose, but yeah.
Oh, that's perfect.
Face.
Absolutely. The UFOs in the news. I'm actually going to talk about that a little bit.
Oh, great.
And our oldest son is outside flying a drone. So there's a lot of aviation and aeronautics.
Okay, excellent. The atmosphere is getting a workout tonight.
Astronomy going on over here.
Hi.
This is one of my teachers from a long time ago. Can you tell us what was gone?
Hi.
Hi.
How long
How are
have you
you?
been at Wittenberg?
Oh, there we go. How are you doing?
Good. I was just wondering how long you've been at Wittenberg.
I've been here about 20 minutes. Sorry. You know what? The later it gets in the evening, the bigger smartass I become. So longer than I care to think, probably 97. I got here as a adjunct.
Yeah.
Then I became visiting, then assistant, then associate, then full, and now I'm emeritus. So I've tried every adjective. And throughout my career here, I find, you can be oh so clever or oh so pleasant. And for years I was clever. I recommend pleasant. I got that from Jimmy Stewart in Harvey, the movie with the big white rabbit. It's invisible, so I act like it's a big white rabbit. But
What did you major in, if I can ask?
I majored in physics when I was an undergraduate. That was at Georgetown in Washington, D.C.
I went to Howard. Go ahead.
Oh, really?
Yeah.
Yeah, those Jesuits would not let me go.
Oh, I know.
And and then I went to graduate school at Rice, and I'm actually going to talk a little bit about my advisor, who was a guy named Bill Gordon. I'm going to show his picture today because he designed and built the most astounding and one of the most successful radio telescopes in the world called Arecibo,
Wow.
which I'm going to show some very, very sad footage of later in my talk. Anyhow, that was at Rice University in Houston, Texas. I got a master's and a PhD there.
Wow.
Then I went to industry for a number of years where I worked in radar cross-section measurement. That's measuring how stealthy you can make objects.
Right.
And then I decided that I really liked teaching. And so I was living in Columbus, and I wrote to all the universities within a 50-mile radius of my house. I had to use a thicker marker to get Wittenberg in there, except for Ohio State. Not that there's anything wrong with that. I just wasn't looking for that kind of teaching experience.
Yeah.
So I heard from Wittenberg, who one of 3 times in my life where by pure dumb luck, I have been in the right place at the right time.
Wow.
And they had just had somebody leave from the physics department, and they were so desperate, they were willing to entertain a guy who had gone from graduate school to industry for 20 years, which is not the normal academic path.
Right. Yeah.
But as I say, they were desperate. They gave me a chance.
Yeah.
And somehow I had some really understanding students those first few years.
Uh-huh.
And I remember one of the first years I took a group to the Air Force Museum for lack of anything else. I figured I'd show them some I thought they'd have a lot more space stuff. They have a lot more aircraft than space stuff. The space stuff is mostly intercontinental ballistic missiles. And so I took a group there, and my then fiance went with me. And one of the students, we were in the gift shop or the bookstore somewhere, and one of the students took my fiance aside and said, "This guy's really weird, but we kind of like him." That student's name was Bixel. And Jill, my fiance told me about it later that day, and it was the first positive feedback I had ever gotten. And I thought, you know what? Maybe I can do this. So yeah, that was 24 years
I have a
ago.
question with you.
Dr. Fleisch, I think that might be me.
With you.
I'm sorry, say that again.
I said, Dr. Fleisch, I think that.
Oh, we froze.
Oh, we've got some freeze action, but I'm going to take a pause at the moment to get started because I know it's late for everybody, but I just want to welcome all alumni and friends to this very special Alumni College experience. My name's Rebecca, and I'm on the alumni engagement team here at WIT, also a 2014 grad. Thrilled to see some familiar faces in there, but also several new. So Dr. Fleisch, you're a popular man.
Would we say popular? No, people are bored.
Well, we program these events virtually so everyone everywhere can tune in. And instead of being in the Science Center, we're going to be in the comforts of our home or backyard. And so if everybody can mute their videos, and if you have questions, feel free to plug them in the chat, and we'll spend some time at the end kind of going over that. I'm sure this is all going to be very exciting. But before we get started, I'd like to introduce Tasha Bell, former Alumni Board President and longtime supporter of Wittenberg. She's going to introduce Dr. Fleisch for us tonight.
Like supporter of Wittenberg, like she gives money? Oh my God, Tasha.
Lots of
Oh, there she is. Wow.
How's it going?
Pretty good. How are you doing? You look fabulous. You look marvelous.
So, thank you so much. So I have the pleasure of introducing Dr. Fleisch. So I'm Tasha Bell, and graduated in 2007. And so as a physics major at WIT, I had the pleasure of having Dr. Fleisch in class, and he was a great professor, but an even a better person. So
no, you're lying.
He talked about some of his background as I joined in, but just want to talk about, some of his accomplishments. He joined Wittenberg's faculty in '98, and in 2004, he actually received Wittenberg's highest faculty award, so the Alumni Association Distinguished Teaching Award. And as a former alumni board member, we take that award really seriously. And, it is the highest honor at Wittenberg. So really neat that Dr. Fleisch won that. And then in addition, in 2010, he was named Ohio Professor of the Year. And then in 2013, he was named one of the top 25 STEM professors in Ohio. So we at Wittenberg obviously know he's great, but it's pretty neat that the state of Ohio recognized his greatness as well. In addition to, his teaching, he's published some books. So A Student's Guide to Maxwell's Equations in 2008. And since then, he's also published several other A Student Guides books. And to me, it's no surprise that he continues to publish these books that help make physics really understandable and approachable to students, because that's exactly what he does as a professor. And I know I can personally attest to that from my experiences at Wittenberg. And like I said, he cares about his students in and out of the classroom. I still remember during my senior year, I was walking through the hall and passed him in a stairwell, and he asked how I was doing. And actually, I was having a rough day because my car wouldn't start. And he said, "Well, I've got an extra car. I'll give you the keys, and you can just use my car until your car's fixed." And I was like, "What? Huh? Like, who does this?" Dr. Fleisch does. And so, that's just the kind of person he is. And, even though that was 14 years ago, it's something that's really stuck in my mind and heart. And so without further ado, it's my honor and pleasure to introduce you to Wittenberg Professor Emeritus of Physics, Dr. Dan Fleisch.
Wow. That's it. I'm not going to say anything else. We'll call it a day here. That was wonderful, Tasha. You are a special, special person. So.
Thanks, Dr.
All righty. Okay. Well, thank you, everybody. I really appreciate those of you who have shown up for this. I'm going to share my screen in a minute. I'm sorry, I got here a little late. I actually lost my keys to the observatory, and I have no idea where they could have got. Wait, oh my God, it's that vaccination. Anyhow, okay, I'm not magnetic. Well, I'm magnetic, but in a different way. You know, there was a Gilligan's Island episode where Gilligan became magnetized, and that was a comedy show. I cannot believe that here in Ohio, we have people testifying before Congress that, yes, they've been magnetized by a vaccine. But I'm not a biologist, so who knows? Yeah. Okay, so let's see. Share my screen. Let's try this. Share. Oh boy. I think this might actually work. Oh, this is a sign I hung on the door of the, there's been people banging on the door of the observatory tonight. And this is a sign I hung on there. I thought maybe it was a little too smarmy, but you know. All right, so yes, tonight's virtual event. Okay, so here's what I'm going to talk about. What's new? Because people always want to know astronomy news. And, you know, there's news about Mars, there's news about some other things. There's even UFO news. I'm going to talk very briefly about that as well. And then I'm going to talk about what's up in the sky. I was really hoping to show you a live view from the through the telescope, which I can do now. We've gotten this new equipment that lets me do that. It's pretty hazy up there, and of course, it's not dark enough yet. But in another half hour or so, I'm going to take another look, and if the haze has passed, then we will take a live view through the telescope. If not, I'm just going to show some pictures and pretend it's a live view through the telescope, because how the hell can you tell, right? Okay, so what's up? We'll start with that. Oh yeah, I can't even start with that because there are a couple of things that it really helps to understand. If you want to know about objects in the universe and their locations, you got to understand a couple of things about distance units. And every time I give one of these talks, even to people who have taken the astronomy class, afterwards they say, you know, it wouldn't have hurt to do a little review of exactly what's a planet and what's a moon and a star and a nebula and a galaxy. So I'm going to go briefly through what all these different things are. But I'm going to start with distance units. And the first is the astronomical unit, which is a distance unit that's really good for our solar system. If you're talking about distances like from here to the sun and Pluto, we use what's called the astronomical unit, which is the average distance from the Earth to the sun. It's got to be average because our orbit is not a perfect circle. It's an ellipse, like an oval. And therefore, sometimes we're a little farther from the sun. Sometimes we're a little closer to the sun. And that's why, for example, the eclipse that happened yesterday morning was called an annular eclipse, where the moon was not quite big enough to block the entire sun. That has to do with the combination of the moon's orbit around us and our orbit around the sun. So, astronomical unit, 1 from here to the sun. It's about 150 million, sorry, 150, wait a minute, 150 million kilometers. 150. I got too many. Oh, there's a decimal point missing there. This one's right. 150 million. I've shown this like 80 times. I just noticed I forgot the decimal point. And here's a better one. 93 million miles. That's easy to remember. On the first season of Who Wants to Be a Millionaire, if you had known the distance to the sun was 93 million miles, you would have won $1 million. So there you go. If you feel obligated to send me any portion of that because I just gave you that piece of information, I'll send you my physical mail address in a minute. Here's another unit that's more useful if we're talking about like stars and things beyond our solar system. That's called a light year, which sounds like time because it's got the word year in it, but in fact, it's a unit of distance. It is in fact the distance that light travels in a year. That is about 6 trillion miles, or that's 6,000 billion miles, which is about 63,000 astronomical units. So the reason we need these different distance units is because things are so gosh darn far away in the universe. By the way, you say, wait, light travels? Yeah, it's not infinitely fast. It travels at about 300 million meters per second. That's 186,000 miles per second. So it takes light from the sun about 8.5 minutes to get here. I'll talk about some other light travel times in a minute. So here are some distances that are handy to know. You can jot these down if you want to, just kidding. Earth to sun, sun to Earth, about 1 astronomical unit. Mars is about half again as far from the sun as we are. That's about 1.5 AU. Jupiter is about 5 times farther from the sun than we are. Saturn 10, and I skipped a couple of planets here. Pluto has a very elliptical orbit. It gets as close to the sun as about 30 AU and as far as about 50 AU. The nearest stars, now we got to switch over to light years because I'm going to be saying thousands and thousands of AU all the time. So the nearest star, which is Alpha Centauri, or actually a member of its cluster called Proxima Centauri, that's about 4.3 light years away. So if you look up tonight at Alpha Centauri, well, you shouldn't do that because it's only visible from the southern hemisphere. But if you're in the southern hemisphere and you look up at Alpha Centauri tonight, you're seeing light that's about 4.3 years old. That's how long it took it. Traveling 186,000 miles per second, took it 4.3 years to get here. Most stars you see in the sky, like the stars in the Big Dipper, the Summer Triangle, things like that, they're about 80 to 120 light years away. There are some exceptions I'll talk about. The farthest star in the Summer Triangle is over 2,600 light years away. If you want to go to the middle of our galaxy, I'll describe where that is in a minute. That's about 25,000 light years. And the nearest big galaxy to us, is the Andromeda Galaxy, which you can see without a pair of binoculars, without a telescope, just using your unaided eye. We used to say naked eye, but too many websites block us if we have the word naked in there. So the unaided eye, meaning no telescope, no binoculars, 2.5 million light years away. This thing is so bright. Well, it's got hundreds of billions of stars in it. It ought to be bright. You can actually see that if you're away from city lights. If there's no moon, you can actually see the Andromeda Galaxy with your unaided eye. Okay. Now, we're going to talk about some of these objects. Everybody knows what a planet is. The only reason I bother with this is because while some of you were taking the astronomy class, astronomers decided we weren't exactly sure what a planet is. We now have a definition because everybody thought, yeah, it orbits the sun, right? Well, then they started finding a lot of stuff that orbits the sun that they didn't want to call planets. So they made up some rules. They say, okay, to be a planet, if you want in the planet club, you got to have sufficient gravity to pull yourself into a rounded shape. What they mean here is spherical. Round describes a circle, a 2-dimensional object. Spherical drives a 3-dimensional object, like a ball. Pretty surprising to me they used rounded rather than spherical. Not perfectly spherical, because no object, no planet is perfectly spherical. We tend to bulge in the middle, but well, we do, but planets do as well. And therefore, they say a rounded shape. They don't want any of these potato-like asteroids applying for membership in the planetary club. They also say it cannot have enough mass. It has to have insufficient mass to cause nuclear fusion. And what is that? That's the burning, the fusing of chemical elements into heavier elements that goes on inside stars. You don't want stars being in the club because it wouldn't be fair competition if you allowed stars into the same club that planets are in. And finally, here's the most controversial one. They say a planet has to have cleared its neighborhood. This is how they were able to throw out some of the things they didn't want to be planets. The problem is a couple of things that you may have heard of, like Jupiter, has not exactly cleared its neighborhood. So it's a bit of a problem. But they voted on this on the last Friday of a meeting where about 30% of the attendees remained and the other 70% had gone home. And now this is officially these are our rules for what's a planet. Moons are a little different. Let's talk about those. A moon is a rocky or icy body. I've got 4 of them on here. I hope you can see all 4. I'm only seeing 3, but these are the 4 so-called Galilean moons, the ones that Galileo discovered in 1610 going around Jupiter. There's lots of moons out there, but terrestrial planets, that is Earth, the closer planets to the sun, Mercury, Venus, Earth, and Mars, we have very few planets. If you think about it, Mercury has 0 moons, Venus has 0, we have 1, Mars has 2, so that's only 3 moons for 4 planets. Then you get to the Jovian planets, and they have dozens of moons. Jupiter and Saturn both officially have over 50, with about 20 more that are probable or likely, so over 70. Then Uranus and Neptune, they have 70, well, not quite 70, they have about 40 some. So therefore, for some reason we don't fully understand, moons are not uniformly distributed among the planets in our solar system. But you can't be a moon if you don't orbit a planet. Here's the idea, give you the scale of some moons. This is the Earth to give you the scale of the moons. There's our moon in the upper left corner. Mars, you can barely see them, Phobos and Deimos. Those are fitting companions for Mars, the god of war, Phobos and Deimos, fear and terror. Then here are Jupiter's moons. Ganymede, been in the news lately. We just sent a spacecraft to within 650 miles of the surface of Ganymede. It's the biggest moon in the solar system. They used to think that was Titan, which is this moon of Saturn right next door on this chart. That moon actually has an atmosphere. But Ganymede has a magnetic field, which most moons don't. So there's some interesting stuff going on, some of the moons out there beyond the terrestrial planets. Triton is also a pretty big moon. That's a moon of Neptune. And Charon is one of the moons of Pluto, although Pluto and Charon aren't that different in size. So it's not like one orbits the other. It's like they kind of jointly both orbit a point in between them called the center of mass of their system. So those are some ideas of the moons in our solar system. Sorry, Plum Street. The Plum Street races I was explaining before we started. This goes on until 3 o'clock in the morning. Okay, exoplanets are slightly different from planets because an exoplanet doesn't orbit the sun. It orbits a star other than the sun. This is actually the first good image of an exoplanet. You can't really see most exoplanets because the star itself is so bright, but we now believe that if all stars don't have planets, we're not sure, but we think most do. The current exoplanet count is about 4,800 of them distributed among about 3,500 systems. A number of systems have more than one exoplanet. So they're like versions of our solar system. We don't call those solar systems because we have Sol, the sun. We call those stellar systems. How do we find those? You guys may remember, those of you who took the class may remember this. The 2 ways are the wobble method and the transit method. By the way, you say, can't we just look? Yeah, it would be like looking for a mosquito near a lighthouse searchlight. Even if you were sensitive enough to see the mosquito, you would be blinded by the light of the lighthouse. So the star itself is so bright, how are you ever going to see the little exoplanet orbiting it? So instead, we have to detect them indirectly. And here's one method. This is the transit method. If the geometry is just right, the planet, that's this little dark spot, goes in front of the star once per orbit, and the light of the star dips. We don't see an image like this. We just see the light of the star getting a little bit dimmer for a little while. And notice how fine this scale is. This isn't like half as bright or 1/3 as bright. It's like 0.02. It's like 99.98% as bright for a little while, and then it gets to full brightness again. So what we're seeing is this diminution in brightness caused by the transit, that is the little eclipse of that planet going in front of its home star. You say, yeah, but what if the whole orbit is tilted so it never goes in front from our view, like if we were underneath the system or on top of it? Then this wouldn't happen. It's a hint as to how many stars are out there that we've got lots and lots of examples where this happens. So there must be even more examples where this doesn't happen. Okay, here's the wobble method. This is where in class I do that little dance where I like wobble. Might help to turn your audio off. Thank you. So what happens when a planet orbits a star is the star tugs on the planet. That's why it goes around. But the planet tugs on the star. That means if we're down here, the star, we don't see it wobbling back and forth. That would be far too little motion for us to see. But we see it going away and coming toward, going away, coming toward, going. Okay, I think you get it. You can't tell that by just the light, except if the light has these dark bands in it. These are called spectral lines. They're produced by elements in the atmosphere of the star, absorbing certain wavelengths of light. And when something is going away from us, those light, the elements, the bands of the dark and light bands from those elements move toward either red light, that's red shifted when they're going away from us, or they move toward the blue end of the spectrum. So when a star's light turns a little redder and a little bluer and a little redder and a little bluer, that's called the Doppler shift. It works for sound too. Like when a race car goes by and you hear its engine noise go, "Eeeew." When it's coming at you, that's a high frequency noise. And then it goes by you, that's a low frequency noise. Well, the equivalent of light is color. So you're going from high frequency light, bluish, to low frequency light, reddish. And this wobbling star produces wobbling light. That is light that turns a little bluer and redder. By measuring that, we can tell something about the planet going around the star. Does that really work? Yeah, look at this. We have found over 4,500, the count as of yesterday was about 4,800 extrasolar or exoplanets. About 76% of them by the transit method, the darkening when the planet goes by. About 20% by this so-called radial velocity. That's the Doppler shift of the light. And there are a couple of other cool effects that I won't talk about tonight unless somebody really wants to hear about them, called microlensing or even direct imaging. That's just a few percent. So we're getting better at finding planets going around other stars. And there's a lot of them. Okay, here's a pretty cool system. It's called Trappist-1. I'll just give you an idea. Look at how many planets, every one of these dips is a different planet going in front of the host star. This is not a real image. This is a computer simulation, and they don't orbit this fast. But here's the idea. See all these different planets whizzing by? Here's the starlight dipping every time a planet goes in front of the star. That's a pretty cool system. It's called Trappist-1. They tend to give the planets lowercase Latin letters like A, B, C, D, E, and Trappist-1 refers to the host star. Here's what we know. Never believe that these pictures represent reality. We can get an idea of the mass and guess at the size of these things, whether some are nice and Earth-like blue or, looking a little reddish or whatever. We don't know much yet. Soon, we will have a new telescope called the James Webb Space Telescope, scheduled to launch in October or maybe December. But by the way, important parts of it designed by a Wittenberg graduate. That new telescope will replace the Hubble. Nothing will replace the Hubble in the hearts of many astronomers, but it will be a more sensitive telescope that will actually allow us to measure the atmosphere of planets. And then we will be able to tell if some of them have water vapor or heavy elements or whatever as part of their makeup. Okay, on to stars. What's a star? It's a ball of gas in which light elements like hydrogen and helium are being fused into heavier elements like carbon and iron and heavier things. So the sun is a star in which hydrogen is being fused into helium, mostly. So picture some of the members of the class and I took of the sun through a very special filter. You can see some of these features on it. These are some spots on the sun. Astronomers, very technical name for this. We call these sunspots. And these things on the side, these are giant jets of gas. To give you an idea of scale, you could fit 100 Earths across this. And if you can fit 100 across, remember volume, 4/3 pi r cubed? So you take 100 cubed, 100 times 100 times 100 is 1,000,000. You could fit 1,000,000 Earths inside our sun. And our sun is not a big star. We actually call it a dwarf star. So stars are big. This one, our sun, puts out a fair amount of light and other energy, about 4.2 million billion watts of power, most of which we don't use. It's better to dig oil out of the ground and use that, right? Sorry, let me not go on about why we're not using more solar power. It's free for the asking. All right, how many stars are there? Well, if you go out on a clear night, not like this, and you're away from city lights and there's no moon, you might see 2,000. That's if you're in a really good sight. Around here, I'm lucky if I see 100. But in our galaxy, we live in the Milky Way galaxy, there are some 400 billion stars. This is a picture near the center of the galaxy. These little dots, these are not grains of sand on a beach. Every one of these is a star that would hold more than 1,000,000 Earths. And even more. Ours is not the only galaxy. We think there may be 1,000,000,000,000, that's 1,000 billion other galaxies. So in our universe, what I call the known universe, what we can see, there are about 400 billion trillion stars. So when people ask me, are we alone? I'm thinking, probably not. That doesn't mean I think UFOs are visitors from those stars. Okay, we'll talk a little bit about a nebula. This is the Orion Nebula, the great nebula in Orion. If you contact me during the winter, I'll show you where you can look at this thing. And even with a pair of binoculars, you're going to be very happy to see this. With a small telescope, it's wonderful. It's where stars are being born out of hydrogen gas, pulled together by its own gravity, or stars are dying and blowing off their outer layers, making gas clouds. That's what a nebula is. Could be a star being born, could be a star dying. Galaxies, as I mentioned, are collections of billions of stars. We live in one. This is a picture of the Andromeda Galaxy. We live in the Milky Way galaxy. You say, wait, we live in a galaxy. How can you take a picture of something we're in? Well, we live in the disk of the galaxy, and we're a little more than halfway to one edge. So if you look toward the middle, you see a lot of stars in the plane of the galaxy. But if you look above or below the plane, you see fewer stars. So this is our galaxy seen from within. And of course, black holes, everybody's favorite object. This is actually a computer simulation of what the light around a black hole, you may be thinking, wait, if it's a black hole, how can it give off any light? Well, it can't from inside something called its event horizon. But if you're just on the edge of that or a little bit outside, you can get quite heated and give off light. And that light follows very tortuous paths because of all the gravity of the black hole. And that's what this thing looks like. This was designed by an astrophysicist named Kip Thorne, who was designing it in the computer for a very special project called Interstellar. Matthew McConaughey. All right. I don't know. Matthew McConaughey. It was one of the very, very shirtless Matthews who made a movie that featured this particular simulation. Interstellar? Yeah, something like that. Okay, so where are we? This is not a picture. This is a drawing. This is what they used to think our Milky Way galaxy looks like. Now we believe there's what's called a bar across here, but this just gives you an idea of scale. About 100,000 light years across our galaxy. We're a little more than halfway toward one edge. That's where the sun is. We're in a spiral arm. That's just a group of stars called the Orion Spiral Arm. And most of the stars you see in the night sky are in our local vicinity of our galaxy. Have we ever traveled out of our arm of the galaxy? Not even close. Even the farthest traveling spacecraft, these Voyager spacecraft, which we launched in the 1970s, they are less than 1/100 of a millimeter away from our location on this drawing. That's how tiny a region of space we have explored in situ. That is by actually going there. So if you want to explore the universe, Probably better to do it remotely rather than attempting to travel there. Here's an idea of how close or far the galaxies are. As I said, the nearest big galaxy to us is the Andromeda Galaxy. That's about 2.5 million light years away. And this is how long it takes light to travel across the various things. As I said, 4.3 years to get to the closest star across our so-called local group of galaxies, about 10 million years. Across the universe as we know it, about 100 billion years for light to get across. If you want to travel in a spaceship, our fastest spaceship travels about 36,000 miles an hour. Here's how long it would take to go. If that spaceship went to the moon, remember, it took the astronauts about 3 days to get there in the 60s. Now, at 36,000 miles an hour, you can get to the moon in about 6 hours. To get to the sun would take about 100 days, Jupiter, year and a half. Pluto, 8.5 to 14 years, the closest star at the fastest speed we can travel today, 80,000 years. Most visible stars, a few million years. Across our galaxy, 4 billion years. Across our, okay, you see the idea. It takes a long time to travel anywhere. You might say, yeah, but what if we develop technology that lets us go faster than 36,000 miles an hour? Oh, we will. But how much faster? Every mile an hour you add takes more energy. And pretty soon, you're not using the energy you can carry in a fuel tank or even in a small moon that you're dragging with you. You are taking planets worth or stars worth of energy to get up to those speeds. Is that really ever going to be possible? Who knows? But the worst news is there's a speed limit that we don't think can ever be violated. It's called the speed of light. And if you go faster than that, some really weird things happen. Like events happen before the causes of those events. And that we don't think ever happens. So as of our physics today, we think the speed of light is an ultimate speed limit. I'll be happy to talk more about that later if you want to. Okay, so what's new? I'll speed through this. I do have to talk about one sad event, and then I'll show you some images. This is the Arecibo radio telescope. You may have known about this. It was in a place called Arecibo, where they make the rum down in Puerto Rico. My grad school advisor built this place in the 1960s. Sorry, little feedback. So here it is, this white triangle, 600 tons. Well, then they started adding more equipment over a spherical dish. It's a radio telescope. Didn't take pictures. It received radio waves. It's also a radar. You could also send out radio waves from it. And it was in Puerto Rico since 1963. It was the most sensitive radio telescope on the Earth. Here's my advisor. This is Bill Gordon from Cornell. He went to Rice when I got to Rice, and I was very lucky to convince him to be my advisor. Here he is when he built Arecibo. Here he is as I knew him. He passed away a few years ago. But last December 1st, these are a few of its discoveries. I will only tell you this radio telescope made some of the most astounding discoveries, figuring out the rotation rate of Mercury, figuring out our ionosphere, the charged particle layer, making the first radar maps of Venus. They used Arecibo to make sure the astronauts weren't going to sink into the moon in 1969 when Neil Armstrong wanted to take his one small step for man, or a man. He might have had Arecibo not confirmed that the surface was solid enough to land on. It might have been, that's one, we're drowning in moon dust, step for man. So Arecibo was extremely useful. And then last December 1st, this happened. You probably won't hear sound on this. I get physically sick when I see this. There's also a drone, some drone footage. This is the top of one of the 3 supporting towers. And these are the cables that held the central platform up. And one of these cables had started to fray, and then this happened. And here's the platform. No one, thankfully, no one was killed. Absolutely sickening. Okay, sorry for that bad news. That was December 1st. We don't know what we're going to do. There may be an effort. This is devastating for the local economy in Puerto Rico, where a lot of engineers and technicians would stay in the local community. We did our best to try to always support the community. And a lot of students came to the observatory and then went on to go to graduate school, either in the US and then return to Puerto Rico. It's not at all clear the money exists to replace this invaluable facility. But okay, I'm going to move on to happier things. Oh, not again. Okay, so some recent astounding images. The planet Mars, but I'll do the close-ups. You guys remember this thing? We call it Percy. This is Perseverance, landed on Mars a few months ago. Here it is being lowered to the surface. This is truly stunning. This picture was taken by the Sky Crane, which we launched with this guy to lower the rover to the surface. The rover took pictures looking up. Sorry, the door just slammed. Little momentary heart glitch here. This is looking up at the Sky Crane as it lowered the rover to the surface. The cables then severed, the Sky Crane blasted away and crashed elsewhere on the surface. Here's what the rover has seen so far. They named this is a place called Jezero Crater, which is an alluvial fan on Mars, where there was once apparently a river on Mars. It's now a dried riverbed, and they named this mountain Santa Cruz Mountain. This is a focus test for one of the color cameras called Watson, which is part of a larger instrument called Sherlock. They have a bit of a sense of humor. Going to get some nice close-up views of the surface. This is the remnant of the river Delta. This is called Valles Marineris, the great valley on Mars. The Grand Canyon would fit about 15 times in the length of this, about 10 times in the width, and this is about 4 times deeper. It is the most spectacular feature imaginable. Now, these things called RSLs, recurring slope lineae. They are features that change with the season. Is this some kind of liquid flowing out when it comes summertime on Mars and the temperatures warm up? Or is it just material that liquid is pushing to the surface? We don't know. But liquid is really interesting on other planets. There's not a lot of it, but it's interesting when we find it. These are some of the, this is a close-up of some of those lineae. We actually take pictures of other spacecraft landing on Mars. Here's the Curiosity rover being parachuted down onto the surface, taken by another spacecraft called the Mars Reconnaissance Orbiter. And here it is doing its job, roving around, taking pictures and samples, etc. Looking for not necessarily life, although that would be great if something walked up and knocked on the rover's door, but looking for conditions that might be amenable to life. This picture, I thought, for all the world, was taken in the American Southwest somewhere. This is on Mars. This is another planet. It's called Mount Sharp. And it is stunning to me that we live in a period when we get views like this from other planets. Okay, some images of Jupiter. Jupiter has the most crazy turbulent atmosphere. This planet is 10 times bigger than Earth in diameter, and that means, and it rotates in 10 hours. So that means that you get incredible structures in its atmosphere, hurricane-like things in its atmosphere, and spacecraft. These, I know it looks like art. These are actual photographic images. By the way, we do enhance the color. So if you flew to Jupiter and looked at the atmosphere, it would not look like this. But if you enhance the colors, these are real colors that are there, but we just, cranked up the contrast a little bit, the hue. And June 7th of this year, Juno, one of the spacecraft orbiting Jupiter, flew very close to this moon, the largest moon in the solar system, Ganymede, and took incredibly detailed images. Here's a close-up of the surface taken 4 days ago. Saturn, this is a backlit picture of Saturn taken. We never see this from Earth because the sun is behind Saturn. Saturn is 10 times farther from the sun than we are. How could we ever get behind it? Well, you send a spacecraft behind it, and then you get this backlit image of Saturn. I think that is one of the most beautiful images of a solar system object I've ever seen. This is one of Saturn's moons. My favorite moon is called Enceladus. Looks like good powdery snow skiing conditions on this moon. This moon, a lot of dirt on the side that is the leading edge. As it orbits, it keeps one side always in front, and this is the rear side, and the leading edge tends to accrue dust and debris as it orbits Saturn. So this is the moon Iapetus orbiting Saturn. This is Pluto and its moon Charon. As I said, which is the moon and which is the planet? Not sure we can decide. They both orbit the common center of mass. Close-ups of Pluto's frozen methane mountains taken by the New Horizons spacecraft as it's on its way past Pluto and out into the outer reaches of the solar system. And the Europeans sent a spacecraft to this comet called Churyumov-Gerasimenko, and you see some blasts of material coming off a comet. That's what gives comets their long tail. And this is a vent. My cursor there, my cursor is coming and going. This is a vent on the center rock of this comet, and that's where some of the material blasts out. If you want to know what it's like on the surface, this is unbelievable. An amateur astronomer got a bunch of NASA images and stitched them together into a movie. This is actually what it looks like on the surface of this comet's central core. The streaks, by the way, are cosmic, extremely energetic cosmic particles. We call them cosmic rays. And the snow-like stuff are probably hits, not real snow, but probably hits on the imaging sensor by some of those cosmic particles. Okay, a little farther out, we have things like stars that are exploding. The star right in the middle, please come back, cursor, oops. Well, it's just not going to cooperate. There it is. Star right in the middle has blown off its outer layers into what's called the ring nebula. Remember I said nebulae are clouds of gas that can be stars being born or stars dying. Our sun is going to do this in about 4.5 billion years. It's about halfway through its 10 billion year lifetime. And when that happens, we probably want to be on planets, not even planets around our sun, planets farther out, because it's not going to be pleasant. Our atmosphere is going to go away for sure when our sun blows off its outer layers. Here's another starburst region. This one's called RCW 49. It is absolutely stunning that new stars are being born and we get to watch the process. I do not want to imply that over a month or a week or a day, new stars come flickering into being. This is a process that takes tens of thousands to millions of years, depending on the mass of the star. But it's like watching, learning about tree growth by watching a forest. You don't watch one tree grow from a sapling to a full big redwood, but you look at a sample of some young ones, some middle-aged ones, some old ones. Same thing applies to stars in this kind of nebula. And now we get to the realm of other galaxies. This is my favorite from when I was a kid learning about galaxies, the Sombrero Galaxy, for obvious reasons. The dark band is just dust and gas particles that have absorbed some of the light coming from the central core of this galaxy. Sometimes galaxies interact. One galaxy pulls on another and brings long streams of stars streaming out of the galaxy. We call that one the tadpole galaxy. And sometimes We look toward the center of our galaxy, and what do we see? Nothing. Well, not quite nothing. This isn't a computer simulation. These are actual, well, the dashes and dots are. The white things are actual stars. The red cross is the very center of our galaxy. And what do we see happening here? Stars are orbiting around nothing. There is nothing there. No light coming off. And look at this star coming in from the upper left. This is over a period from about 1993 to about 2004 or 5. Look at this star coming in from, swing. What could cause a star with enough volume to hold 1 million Earths to reverse its path like that? A black hole, a very special kind of black hole. Not the kind of black hole that gets born from a single star, but the kind of black hole that has a mass of tens of millions or even a few billion stars. We now think every galaxy has a black hole, what we call a supermassive black hole, right at its center. And where did they come from? We don't know. Okay, we do have our first picture. You probably saw this in the news. Galaxy, black hole at the center of a relatively nearby galaxy called M87. A black hole is in the middle. This is some of the hot material falling through the event horizon, giving off a lot of X-rays, but also visible light as it gets drawn in. All right, I'm aware we're burning through the time. I always show this at class. Some of you may remember it. It's the Hubble Deep Field. You see all these pictures of stars? They're not stars. Everything in this picture, with the exception of two small things, every other thing in this picture is a galaxy. Hundreds of billions of stars, hundreds of billions, hundreds of billions, hundreds of billions, hundreds of, I think you get the idea. And in this little piece of sky, which is, imagine picking up a grain of sand and holding it at arm's length, covering that much sky. That's how much sky is in this picture. A grain of sand's worth held at arm's length. And there are over 2,000 galaxies in that little bit of sky. If you extrapolate that to the rest of the sky, and we have no reason to think that this bit of sky has any fewer or more galaxies than any other part of the sky, that's where we get the estimates that there are hundreds of billions of other galaxies, maybe 1 trillion other galaxies. Okay, where can you find images such as this? One place I always recommend people take a look, the astronomy picture of the day, the APOD. Here it is. If you don't remember this, just Google astronomy picture of the day. It's a NASA.gov APOD site, and they have wonderful pictures, good explanations, one that works for anybody, and then a more detailed explanation if you want a little more technical information about that particular image. And they keep an archive, so you can scroll back and look at pictures from the past that you might find interesting. Astronomy picture of the day. Okay, I got to talk about this. You've probably seen some videos lately. You know, the government is releasing the report, right? A lot of images like this. This is infrared image taken by a pilot who had his infrared camera. That's a heat tracking camera. And there are a number, few dozen to a few hundred objects that behave very weirdly in the sky. Astronomers often get called on to comment on this. I have no special expertise in these particular videos. I can tell you that, as you heard from Tasha, before I became a faculty member, I did research in radar, and we did tracking radar, measuring things, sometimes things that are moving. So I have some experience with optical tracking systems, which this is an infrared version. And I can tell you that what I see here looks like a lot of things that we did not understand, but were clearly not alien spacecraft. I can say that because we ultimately were able to track down what they were. But aren't they behaving weirdly? Aren't they defying the laws of physics? No, we just didn't understand what the camera was doing. The camera is on a thing called a gimbal, and the gimbal is moving, and the aircraft is moving that takes the images, and the thing itself might be moving. So, are they UFOs? 100% certainly they're UFOs. Unidentified flying object. We don't know what they are. Are they aliens? I think they're of terrestrial origin. I don't think they're of extraterrestrial origin. I will tell you, I worked on a few programs where we had things we didn't want anybody to know we had. We were delighted when some of our things would appear in videos and people would say, ooh, alien spaceships. Why were we delighted? Did we like fooling people? Not exactly. We just liked not giving away what we had. So I'm a skeptic. Feel free to disagree with me. This is one of those things where you can do a lot of good research. Be careful on the web. A lot of people put stuff on the web, like becoming magnetized from vaccines, that you probably should look for other sources for. But if it's a .gov site, if it's a .edu site, or if you contact me, I'll be happy to point you at sites that might help clear up what some possibilities are for some of these things. I don't want to be a killjoy. Okay, well, maybe I do in that case. What's up tonight? A few things. I'm just going to show you a few things. I see it's 9:57. So what I'm going to do is I'm going to stop sharing this screen. No. Stop sharing this screen. Screen sharing has stopped. And I'm going to try to share another screen. Are you guys seeing a bunch of stars? Somebody speak up for the group and tell me whether you're seeing a bunch of stars.
Yes.
Good, thank you. That is so helpful. For some reason, a lot, you know what, I just realized it's dark in here. All I can see are the reflections in my glasses. Sorry about that. This is a program called Stellarium. You can plot the night sky. It's not a live image of the night sky. It's inside my computer right now, but it's really helpful because you can do things like see what's up there and change the time and take away the Earth's atmosphere, which I've done here. That's why you can see so many stars. Or you can put in the Earth's atmosphere like that. That's more what it's going to look like if you go outside. It's kind of crummy out there right now, so I'm going to keep showing you this. Let me zoom in a little bit. Did I say this is free software? You do not pay for Stellarium, and I really like it. I downloaded this because it shows you things like the Big Dipper. That's these 3 stars in the handle, 4 stars in the bowl. Here are 2 in the end called the pointer stars. They always point right at the North Star. How do I know it's the North Star? Well, if I click on it, it says Polaris. Gives you all the data about it, and it tells you like how far away it is. In this case, it says Polaris is, I always have trouble finding distance on this. "432 light years. That's not the best estimate, but it's about right. So that's really handy. And if you want to put on constellation lines, you just hit C, and the Big Dipper is on there, but it's part of a bigger constellation. The Big Dipper is actually an asterism called the Big Dipper, obviously. But that means it's just a piece of another thing. This is the Big Bear, Ursa Major. And the Little Dipper is part of the Little Bear, Ursa Minor. You say, wait, I don't see, the bear looks kind of like a seal wearing a saddle. If you want, you can turn off the constellation lines and turn on, not the atmosphere, the artwork, not that. The artwork. This is how the ancients saw the sky. There's the Big Bear. There's the Little Bear. There's the famous giraffe constellation, not well known. There are a few others. King Cepheus. Ooh, the swan. Some of you who did sky knowledge may remember the swan, also called Cygnus. Let me get rid of the artwork and put on the constellations. There's Cygnus the swan. Looks kind of like an aircraft, long neck on the swan, and it's got an asterism. Let me zoom in, you can see it better. It's the Northern Cross. So if you go outside, tonight you probably won't have much luck, but tomorrow night or Sunday night is supposed to be clear. Have a look in the east, a little bit above the horizon. You'll see the Summer Triangle. It's the brightest thing up there right now, and it's got 3 stars that are helpful for distances, because this lower one on the right is called Altair. It's part of a constellation called Aquila the Eagle, and its distance is about 17 light years. So when you look at Altair, you're seeing light that is about 17 years old. when you look at Vega, Vega, the brightest one up here, that's in a constellation called Lyra the Harp, you're seeing light that is about 25 years old. That is, Vega is 25 light years away. You may remember Vega from the movie Contact. That's where Jodie Foster's dad lives on the beach for some reason. And the coolest star of the summer triangle is this one. That's Deneb. We don't know how far away Deneb is. The closest estimates we've got are 1,400 light years. The farthest are 3,300 light years away. In other words, if that's right, then the light you are seeing tonight or tomorrow night left there when the pyramids were being built in Egypt. And if there's a planet going around Deneb, and if there are beings on that planet, and if they have super powerful telescopes right now, tonight, if they're looking at the Earth, they're seeing pyramids being built. Because our light takes 3,300 light years to get to them, just like their light takes 3,300 years to get to us. Okay, so if you're going out tomorrow night, zoom out a little bit here, in the east, so between northeast and southeast, looking almost due east, there you will see the summer triangle. Looking to the north, you will see the Big Dipper with its two pointer stars pointing at Polaris. And why do we call it Polaris? Because the Earth's pole, our axis, points essentially right at this star. So the stars move around over the course of an evening, but that's not because they're moving, it's because we're spinning on our axis. And I can make time go fast. And when they make time go fast, see, they're going, uh-oh, it's tomorrow. Wait, it's Saturday. Oh, good. The sun just set. It's tomorrow night. See, the stars are all making counterclockwise circles around Polaris. And why are they doing that? Because we're spinning on our axis, not because Polaris, or not because the stars are doing anything. Okay, let me try to go back to now. Here we are back at now. Whew, that was a brief trip to the future. But I do recommend that if you find the Big Dipper, follow these two pointer stars to get to Polaris. It is always due north. It is the one star that never moves. That is, if you don't change location. If you go to Mexico, it'll be lower on the horizon. If you go to the equator, it'll be right on the horizon. And if you go south of the equator, you won't be able to see Polaris. It is always exactly as many degrees above the horizon as you are above the equator. Here we are in Ohio, 40 degrees north of the equator, and it is 40 degrees above the horizon. Go to Canada, maybe 60 degrees above the equator, Polaris will be up here. And go to the North Pole, Polaris will be directly overhead. If you go to visit Santa Claus and look straight up, you will see Polaris directly overhead. So it's the one star that doesn't move. It's a good thing to know because it's always in the north. So Big Dipper, Polaris, by the way, the Little Dipper, here's the Little Dipper. Polaris is at the end of the handle of the Little Dipper, and usually the only two other stars I can see of the Little Dipper are these two guys at the end of the bowl. Okay, one other star I want to point out, and then I will shut up. If you arc the handle of the Big Dipper, well, don't take it anywhere, just look at it, and you arc, you come to Arcturus. Arcturus is a really cool, bright star, one of the brightest stars in the sky. And arcing to Arcturus sends you to a constellation called Bootes the Herdsman. He's a cool little guy. Here he is. By the way, these constellation figures are not the classical ones. They were drawn by a guy named H.A. Ray. He drew a cartoon called Curious George, but he also drew the very best ways of connecting the dots of the constellations. And so here's Bootes the Herdsman smoking a pipe and watching over some imaginary sheep. And Arcturus is part of Bootes the Herdsman. If you continue, after you arc to Arcturus, you come to a very bright star. That is this star called, it's just not going to land on it for me. Let me zoom in a little bit. Spica. Spica, S-P-I-C-A. It is part of Virgo, the Virgin. I don't see her often here on Wittenberg campus, but there she is. And next to her is this constellation, which is a lion. This is Leo the lion. And he's easy to find, even if I turn off the constellation lines, because his front end is a backwards question mark. See it there? That's the front end of Leo the lion. There's his hindquarters. And this is how H.A. Ray connects the dots. Okay, so those are just a few of the constellations that are up at this time of year. If you contact me and would like a better, more detailed tour of the night sky as our vaccination rate improves and as our COVID positivity rate drops, I will invite people to the observatory once again. Virtually is always possible. In person will soon become another possibility, and I am more than happy to show you around the night sky from here at the observatory. I do have a minimum group size, that is 1. So you must be a complete person in some sense. There's a small test I give to make sure. But if you're a complete person, by all means, contact me and I will let you see stuff and let you look through the telescope from the observatory. I'm turning off my screen sharing and maybe I'm back, maybe I'm not. Are people seeing me? I always like them to be able to, I always like people to be able to see me when they're asking questions so they can see that stumped look on my face when I don't have the slightest idea of what the answer is and I start making crap up. So I'm ready to do that at any time. How did I do? 10:08. All right. Well, there's probably only 2 of you. Thank you very much. I see I see one hand clapping there. Thank you so much. And thank you, Tasha.
Oh my goodness, that was so wonderful. Does anyone have any questions for Dr. Fleisch? We've got lots of hand claps, loves, thumbs up.
Thank you very much. I certainly remember there are no stupid questions. There are some really stupid people who ask them, but that's not true. That's not true at all. I don't think people are stupid. Okay, sorry. On to questions. Why am I so close? Oh, because if I go into the distance, here I go. Oh, I didn't get to show you some of the new equipment we have. Sorry, I got to show you this. Are you able to see this? This is the camera we had. When a lot of you were doing projects, this was the camera. I'm going to try to turn a light on that might shed some light on this. Stand by one. So some of you may have struggled. This monstrosity is the camera we had at the time. We hook it up to the telescope and you do your project. Now, always dangerous to be moving the computer around here. This is a full color camera that does everything the big guy did, except we had to use 3 filters to take individual photos here. Now, better, more sensitive images like this. Look at the size of that. And they're getting even smaller. The one that you see on the end of the telescope here, this little guy is another camera. They're just getting smaller and smaller. And can you believe? Look at this. Can you believe this is a camera? No, it's not. It's a keychain they send you when you buy the other cameras. But don't feel stupid if you thought it was, because I tried for a week to make this work as a camera. It turns out it doesn't work at all. Anyhow, so with cameras like this, we are, for the first time in 40 years of taking astronomical images, I am finally taking some images that I'm not embarrassed to show people. So thank you, Astronomy Club. Thank you, Wittenberg students, for helping secure the money that allowed us to buy these things. Okay, that was a question nobody asked.
We've got are there still rats in the basement?
Oh, I once asked the provost, not this provost, not the previous, but the one before. I said, can we please get those biology rats out of the basement? Here, this is the one place on campus where we're asking people to contemplate the grandeur of the universe, and they're doing it amongst the overwhelming smell of rat feces. So I asked the provost, please can get rid of, and she said to me, those are not biology rats. Those are psychology rats. I go, oh, that explains those little tiny couches I saw down in the basement. Anyhow, the rats are now gone. I have not smelled whatever the smell was. I've not smelled that in over a year. Maybe that's, they say some good things come out of even a pandemic. Maybe the observatory has improved by virtue of somebody not having little rodents in the basement.
Okay, so we've got you'll be offering another virtual tiger talk like this in the near future. Do you have any future events coming up, Dr. Fleisch? I know.
Here's what, in general, I do these only when people ask, or when there's a big event, some big astronomical event. And so oftentimes that will be something that's in the news that there's, I'm not talking about, the super flower blood moon, which for some reason we seem to be getting a lot of in the news media lately, but I mean something real. And when the Astronomy Club is here, which is all semester, fall and spring, we have meetings every 3 weeks, and we often do stuff at the observatory, remotely for the last two semesters. We do stuff at the observatory on those. So anybody can be in the Astronomy Club. So you don't even have to sign up. You just have to, log on to the meetings. So the answer is yes, special events when people request, and Astronomy Club meetings.
Awesome. Thank you. Well, that's good to know. I might join the astronomy.
You are always welcome to.
We also had the question if this would be put on YouTube, and I did want to let everybody know I'm sending it in the link now, but it will be come Monday, Tuesday, it'll be archived there. And so you can rewatch this, share it with alumni friends and all that. You need to rewatch it a couple times for the definitions, probably.
No, I wouldn't advise that. Okay.
All right. One more. We've got everybody saying how much fun it is, how wonderful, thanking you. And then what are your plans April 8th, 2024? I'm guessing that's a big astrological event.
Oh, I know what they're talking about. They're talking about the next eclipse. Remember the eclipse a few years ago? Well, I don't know how many years it's been, where you had to go like to Kentucky. You got a partial solar eclipse I'm talking about, where the moon goes in front of the sun. We had a partial eclipse here, but I was in England where the moon barely grazed across the lower edge of the sun. But here I understand it was pretty good. And if you went to Kentucky, you got what's called totality, where the moon completely, that was a terrible rendition, where the moon completely blocks the sun. And that's the only time, by the way, where it's safe to look at an eclipse without a proper filter. But there is an eclipse coming in 2024 that is going, totality is going right across Springfield. It's coming up, it's going through big cities, Indianapolis, Cincinnati, Springfield, Ohio, and on through Cleveland, etc. Here's my one great concern. Do you remember what month the previous one was? Pretty much August, right? Sometime in the summer. You know when this one is? April. I'm nervous about cloud cover, but I'm not going to be pessimistic. So we will definitely have an event in April of 2024. Well, so in December, I'm turning 70 years old. So I'm telling everybody, if they want stuff in the observatory, the next few years, you're probably safe, but I wouldn't postpone things for more than, 5 years. And at 10 to 15, I'm not the healthiest guy in the world. You're just taking a chance here, but I'm planning on being around for 2024. So yes, assuming the worst does not come to pass, I will be here for that.
All right. Well, thank you so much, Dr. Fleisch. And
you guys.
I'll be be sending out an email to everybody who registered with that link also to the archive. And so you can kind of keep in touch, and thank you so much. Everybody
you,
have a
guys.
great evening.
All right. Have a good one. Thank you.
Dr.
Bye-bye.
Fleisch.
Thank you. Tasha, you are a wonderful human.
Oh, you're the awesome one,
You
Dr.
those
Fleisch.
lies you told about me, you did it with such a straight. Oh, sorry. Are we still on? Just kidding.
Can I ask you a question?
You may
Am I
certainly
late?
ask a question.
Oh, I look creepy. We're Wittenberg grads and we live in Sedona, Arizona, so it's still
Oh,
daylight now.
You're just
But
torturing us.
We have the Lowell Observatory. in
Yes, you do.
Flagstaff,
Percival
which I was
Lowell.
dying to get up to, but it's been closed because of COVID. Have you
Exactly
been
right.
there?
Yeah, yes, I have. This is a wonderful facility. As a matter of fact, one of the biggest telescopes in Ohio for many years was a 60-inch telescope at an observatory near here in Delaware, Ohio. And somebody did a calculation of how many clear nights you have in Arizona and how many clear nights we have in Ohio. And within a year, the telescope was torn out and sent to Arizona.
Is that right?
Anyhow, I'm a huge fan of Percival Lowell. He's a guy who was, he's vilified for many reasons about, he thought he saw canals on Mars, which turned out not to be canals. But he's a wonderful, he was a wonderful guy. And the observatory is still named after him. And they do wonderful outreach. So I strongly recommend that you get up there. When they open up again, get up there on one of their open nights. Don't be too disappointed if you can't look through the biggest telescopes. Many times, there aren't even eyepieces for the biggest telescopes because we're using instruments to gather data rather than just looking. Because when you just look, you can't really make a scientific measurement, right? But with an instrument, you can record things and, take the light apart and do a lot of that. So don't be expecting to put your eye up to an eyepiece and see galaxies. But they often do have medium-sized telescopes that you can look through, and I strongly recommend that you do that.
I know his big thing was apparently that they discovered Pluto there. But now
Absolutely.
they're saying that Pluto isn't a planet. Is Pluto a planet or not a planet?
Here's what it is. It's what's called a dwarf planet, which if is a raincoat a coat? I think so. Is a cell phone a phone? Seems to be. Is a dwarf planet a planet? What you'll hear people talk about is those 3 rules I talked about: clearing your neighborhood, having gravity to pull yourself into a spherical shape, and not having nuclear fusion. Pluto doesn't meet all 3 of those, and therefore it was thrown out of the planet club. But it is a dwarf planet, of which we now have several others, and so it is lessened in no way. But
Okay.
some people are really disappointed that it was thrown out of the planet club because it was a wonderful story of how it was discovered. Percival Lowell predicted where it would be. It turns out he made math errors, and yet they discovered it not far from where he predicted. So he caused it to be discovered, even though he didn't directly discover it.
Okay.
Yeah, he's a good
Could I
guy.
ask another question?
Sure, absolutely.
About I know this is astrology, not astronomy, but
I'm
know
open to all
between
questions.
asterisms and constellations. And
Yep.
the constellations of zodiac, all of a sudden they said there's a 13th.
I know.
What do you
Here's
think about
why.
that?
Here's why. There are a couple of reasons for that. Number one, stars, even though I say they don't really move, we spin on the Earth and they appear to move, stars actually do move as well. They have something called proper motion. So the constellations we see today, in 1,000 years, they're going to look a little different. And 1,000 years after that, they're going to look way different. Here's another thing. If you go off the Earth, the constellation, not to Pluto or, anywhere in our solar system, but if you go halfway across the galaxy, the constellations look completely different. Because the way they look to us is from our point of view, and they kind of project, if you imagine them projecting onto a flat plane, we see a pattern. But if you go around the side, some of them are far away, some of them are close, so you'll see a whole different set of constellations. This just means you get to make up your own constellations. Well, due to proper motion of stars and redrawing the boundaries of what we call a constellation, there is now a 13th constellation. And so astronomers have no problem with it. Astrologers have handled that in various ways. Remember, astrologers were around a long time before astronomers, so They get to handle it any way they want to. We astronomers handle it the way we want to. If you're wondering what astronomers really do with constellations, we just consider them to be borders of regions in the sky. The connecting the dots is not official at all. All that's official is this region we call Orion, and this region we call Ursa Major. So not connect the dots, just regions of the sky. And those regions, there are 88 constellations in those regions, and those have not changed.
Thank you. Yeah.
So, Christine, we had a question from Kristen that I missed earlier. And so, Kristen, did you want to go ahead and still ask that?
Maybe Christian left.
I was wondering, let me see. I think she might have left. Yeah, okay. Oh, wait, no, there she is. I saw her pop.
She's on mute.
Okay.
Oh,
So I can go ahead and let me see. Oh, I missed the question now again. Where'd it go? Okay, so we talk about the known universe. How do we
Yes, we
find
do.
out or know what is beyond the known universe?
great question. And the answer is we don't and we never will. Because as soon as we learn something, it becomes part of the known universe, right? So we expand our reach farther and farther out. Now understand, when we look farther out, we're looking farther back in time. Remember what I talked about? It takes light a while to reach us. So the farther out we look, the farther back in time we look. And we always can get farther and farther and farther, and there are things that we haven't seen before, but they just become part of the known universe. So we don't ever get to see or know what's in the unknown universe. It's not a satisfactory answer, but it's the best I have. Yeah, I know. Hurts my head too.
All right. Well, on that note, does anyone else have any other questions? I think we got all of them. I looked back through. All right. Well, Dr. Fleisch, we've got a lot to think on tonight. I'm sure we're going to
Thank you so much. You guys are wonderful. I really appreciate it.
All
All righty.
We'll
Thank
be in
you.
touch. Take care.
Bye-bye.
Bye.
Thank you.